Hi students, let us learn about oxidation and reduction reactions today. First, let us know about oxidation reaction. So in a very basic definition, we can call oxidation as addition of oxygen to a substance or removal of hydrogen. So when we look at this particular example, phosphorus and oxygen are two reactants, the starting material. They combine to give rise to phosphorus pentoxide. So now here, when you look at left hand side and right hand side, P plus O2. That is, there's a reaction happening between phosphorus and oxygen. And when you look at the product, there is P2O5. So here, there is addition of oxygen to phosphorus to give rise to P2O5. So this can be called as a oxidation reaction. Okay, so this is the very simple definition and a very simple equation that I've taken. But this is not balanced. So we have to balance. So on left hand side, let's take phosphorus and oxygen, and on right hand side also let's take phosphorus and oxygen. So left hand side, the number of atoms of phosphorus is 1, but on right it's 2. So I can write a 2 here. Now coming to oxygen, there's two atoms on left side, but on right side there is 5. So if I multiply, so there's 2 on left hand side and 5, so a common multiple would be 10. So if I multiply oxygen by 5, okay, 5 2s are 10, and here if I multiply by 2, so again it's going to be 5 2s are 10. Now here, since phosphorus now gets 4, so please look at the product. Okay, when you look at the product, there is 10 molecules of 10 atoms of oxygen, but there are 4 atoms of phosphorus. So that's why if I write a 4 here, okay, so now it's going to be balanced. That is 4p plus 5O2 giving rise to 2p2O5. So that is the balanced chemical equation. Similarly, let us take one more example. Iron reacting with oxygen to give rise to Fe2O3, ferric oxide. So now here again, the coming to the balancing of equation, similar to, since I've already in the previous videos I have explained about balancing. So here again we can look at the oxygen. So when you look at oxygen, there's 2 atoms on left hand side and 3 atoms on right. So if I multiply right hand side by 2 and left hand side by 3, so it's going to be 3O2 and 2 Fe2O3. But iron is 4, and I write a 4 on left hand side. So now it's 4 Fe plus 3O2 giving rise to 2 Fe2O3. Okay, now coming to reduction. So again, our basic definition would be addition of hydrogen to a substance or removal of oxygen. Now look at the example. Hydrogen and fluorine both are diatomic molecule. So they are giving rise to HF. So here, if you look at fluorine on left hand side, okay, it's just a diatomic molecule, but on right hand side as a product, it is combining with hydrogen. So there is addition of hydrogen, and hence I call this reaction as reduction reaction. Okay, so now again this is a not balanced equation. So if I have to balance this particular equation, it would be very simple. Write a 2 on right hand side. So there are so let's check. 2 hydrogen on left, 2 hydrogen on right, 2 F2, that's 2 atoms of fluorine and 2 atoms of fluorine on right hand side. So the balanced equation would be H2 plus F2 giving rise to 2HF. Okay, so now let us know the differences between between oxidation and reduction. Addition of oxygen is called oxidation, whereas addition of hydrogen is called reduction. Second difference would be removal of hydrogen is called oxidation, removal of oxygen is called reduction. When we talk about electrons, loss of electrons is called oxidation, gain of electrons is called reduction. So increase in oxidation number or decrease in oxidation number. So if I take an example, sodium, okay, it's a atom, sodium atom, but when it loses one electron, it forms Na plus 1 electron. So here this plus charge on sodium Okay, so there is always loss of electron. So you can call that sodium has lost an electron, so hence you can call it as an oxidation, whereas reduction would be gain of electron. Similarly, increase in oxidation number. See, when you compare sodium and sodium ion, cation, so sodium charge would be 0, whereas sodium cation is positive, that's +1. So there is increase in oxidation number. So that's why oxidation always results in increase in oxidation number, whereas reduction would be, since it is gaining electron, it would be decrease in oxidation number. Example, we can take chlorine. See, chlorine is highly electronegative, belongs to group 17 in the periodic table. So chlorine always has a tendency, since it is more electronegative, it has a tendency to attract electrons or withdraw electrons of adjacent atom. So when it withdraws electron from adjacent atom, it becomes Cl minus. So here what is happening? There's gain of one electron. Gain of an electron. Okay, and similarly when you talk about oxidation number also, there is decrease. So from 0 to -1, there is decrease in oxidation number. So hence we can call this as a reduction. But these are just in general I'm speaking, but when we look at reactions, we will able to understand it much better. So now let's move on to redox reaction. So what does mean by redox? The definition itself is saying reactions involving oxidation and reduction reactions which happen simultaneously, they're called as redox reaction. So in the term redox, we can split the word red. Red stands for reduction and ox stands for oxidation. So mostly the redox reaction is happening simultaneously. That is, reduction and oxidation happens simultaneously. That is, loss and gain of electron. So there's an example here. Copper oxide is heated with hydrogen, then copper metal and water are formed. So when we look at this reaction carefully, it's very clear that CuO as a reactant, and now product is Cu. So here mainly there's loss of oxygen. Okay, so there's loss of oxygen. So hence this reaction, copper oxide to copper, is nothing but reduction. Okay, and the substance which is getting reduced is copper oxide. Similarly, when you look at the other end, that is hydrogen as a reactant and water as a product, so their oxygen is getting added to hydrogen to form water, and hence this is an oxidation reaction. So this is an example for oxidation and reduction, that is redox. So now in the exam, usually how they ask is, they give you a particular chemical equation and ask you to write the substance oxidized, substance reduced, oxidizing agent or reducing agent. So now let us look into it. Oxidized substance which is oxidized is hydrogen. Okay, so here, as I already told you, hydrogen is undergoing oxidation to form water, because oxidation, we know it is addition of oxygen. Similarly, the substance which is getting reduced, that is loss of oxygen, is copper oxide. So substance reduced is copper oxide. Now when we have to understand with respect to oxidizing agent and reducing agent, it's very simple. The reaction which undergoes reduction will involve oxidizing agent, and the reaction which will involve oxidation will involve reducing agent. So now here, as I already told you, CuO to Cu is reduction. So hence CuO will be an oxidizing agent. Similarly, hydrogen to water is oxidation, and hydrogen would be hydrogen would be reducing agent. So it's opposite. Okay, so oxidizing agent, usually students, they are electron withdrawing species. Electron withdrawing can be ions or atoms or molecules, and once they withdraw electron, they are getting reduced. Whereas reducing agent, on the other hand, they are donating. They are donating electrons. Since they are donating electrons, they totally get oxidized. So they are opposites. Similarly, one more example, H2S plus Cl2 giving rise to S plus HCl, sulfur plus hydrogen chloride. So hydrogen sulfide, when you look at hydrogen sulfide, reaction between hydrogen sulfide and sulfur. So here what is mainly happening is, so please look at the reaction between hydrogen sulfide to sulfur. There is removal of sulfur. So there's removal of hydrogen. So hence it is oxidation. Whereas chlorine to HCl, there is addition of hydrogen, hence it is reduction. Okay, so they are opposites. H2S2S giving rise to is an oxidation reaction. Cl2 to HCl is reducing agent. Now the reducing agent and oxidizing agent would be opposite. Okay, so now which is the reducing agent? Since H2S2 hydrogen sulfide to sulfur is oxidation, H2S will be definitely reducing agent. Similarly, Cl2 plus HCl is reduction and Cl2 would be oxidizing agent. So it's the opposite. So please focus on these type of reactions. Thank you.